You made it. This is your last set of notes for algebra for the year. You're going to finish this up today and with your assignment, and then next week assignment is just going to be like a review over radicals, and then you just have 1 week of ALEKS after that without any additional assignments on top of ALEKS, and then a catch-up week. So you guys have made it to your last set of notes for the year. Woohoo! And they're actually pretty simple. So what we're going to do today is we're going to add and subtract radical expressions. So basically it's like exponents or variables. So like 3x, you're trying to add 3x into 2y. You know you can't do that because they aren't like terms, right? This has an x, this has a y. Those are different. You can't smush them together, okay? Now if this was 3a and 2a, they both have just a single a as the variable, so you could add them together, and then you would get 5a. And then this is so natural to us anymore, we don't really pay attention to it, but if you think about it, all you do is add or subtract the numbers in front, and you left the variable and the exponent alone. So we've said this a lot, like if they have to be the same, they stay the same. So the fact that the a's had to match in order to add those together meant that your final answer just had an a in it. Okay, you never change it when it has to match in order to put it together. It has to stay that way when you're done. Exact same thing with radicals. So if we would have just said 3 radical 5 plus 2 radical 5 is the exact same thing that's up above, except now it has square roots instead of a's. So 5 and 5, the radicals, the square roots have to match in order for them to be considered like terms. Since they both have the square root of 5, they match. All you have to do is add or subtract the numbers in front. So 3 plus 2 is 5, and you leave the radical alone just like you would up above. So that answer is 5 root 5. It's exactly like combining like terms with variables. They have to match. You add and subtract the numbers in front, leave the square root alone, because if it has to be the same, it stays the same. And then that's it, okay? So it can be only performed with the same number under the radical. You add or subtract the numbers in front and leave the number inside alone. That's all the things we just said. So if you remember, terms are separated with addition and subtraction signs. So if you want to put your little squiggly lines there, you can. And then you can always underline your first term once. Okay? And then you go to the second term. Does this 6 root 3 match 4 root 3? Yes, because they still have a radical 3. And then the 5 root 3 matches both of them because of the square root of 3. So the square root's the same on all of those, so they all match. So all you have to do is add and subtract the numbers in front. So we're just going to do 4 plus 6. 4 plus 6 is 10. And then minus 5. Just watch your signs. 10 minus 5 is 5. So that's the number in front, or your coefficient, and your radical 3 had to be the same, so it stays the same. And then you're done. Okay? The only trick, I'm sure you're like, I'm sure this gets harder. The only trick is that your square roots have to be simplified before you can make that assumption. Okay? So the square root of 3 obviously isn't divisible by any perfect square, so that one was fine. But if you have like 40 underneath the square root, you have to simplify it first before you can assume whether or not you can add or subtract them together. So always simplify the square root. So I can't just look at this. So here I have 2 terms. I can't just be like, oh, radical 8 and radical 32, they don't match, so I don't have to worry about it. That's not true, because you know they're divisible by perfect squares. So 8 has to split. The biggest perfect square that divides 8 is 4, and 4 times 2. Don't lose this 5 that was out front. Okay, you can't lose the number in front. So the 5 just came down, the 8 split into 4 and 2. It doesn't change the fact that this 4 has to come out as something different. So this 5 drops down, 4 gets to come out as a 2, and in your square root you have a 2. Okay, so the 5 has followed us through all the way. 8 split into 4 and 2, the square root of 4 came out as a regular 2, and then that 1, 2 stayed inside. Now the only thing left is that 5 times 2 is 10. So that entire term simplifies to 10 square root of 2. because once you have multiple numbers outside, you just multiply them together. Okay, then we'll move on over here and we'll do the square root of 32. So this 2 will just drop down. 32 splits. The biggest perfect square that divides 32 is going to be 16 times 2. Make sure you're getting the biggest perfect square. Okay. Then this 2 again drops down. 16 gets to come out of jail as a 4 because the square root of 16 is 4. And then the square root of 2 is still inside. Then the last thing, you just multiply the numbers in front. 2 times 4 is 8 root 2. Drop the addition sign down, and now you can evaluate. Now that you know each of these has been simplified, now you can say, okay, can I add these two things together? Well, now they're both the square root of 2, so they're in like terms now, so you add or subtract the numbers in front, so just 10 plus 8, which is 18, and you leave the square root alone. So you just treat each term like it's its own problem that you've been doing and simplify it, and then you decide whether or not you can add or subtract them. And then just remember, when you're doing that, the square root has to be the same so it stays the same. Okay, let's look at 2 more. This one has 3 terms, so we're just going to do all 3 of them separately. So 20 is divisible by a perfect square, so we'll drop this 2 down. The biggest perfect square that divides 20 is 4 times 5. 2 drops down. The square root of 4 is also 2. And then inside your square root is 5. On the outside, you multiply your coefficients. 2 times 2 is 4. 5 is in your root, so that whole thing reduces to 4 radical 5. I'll drop the addition sign down now, and we'll come back to it later. We're going to move on to this term. The 3 will drop down. 45 is divisible by 9 and 5. Again, drop your 3 down. The square root of 9 is also 3, and 5 stays in the root. Then you go ahead and you multiply the numbers in front. 3 times 3 is 9, radical 5. Scoot over, drop the subtraction sign down, and come on over here to 180. Okay, so 180 doesn't have anything out front, so you don't have to worry about that. The biggest perfect square that divides 180 is actually 36 times 5. And then the square root of 36 is 6, and the 5 stays inside, and since there wasn't a coefficient out the front to begin with, you don't have to worry about multiplying the 6 by anything when you bring it out. Okay, now that I have that all simplified, now I can look at smishing them together. They are all actually ended up being the square root of 5, so they all match. So 4 plus 9 is 13, and then 13 minus 6 is 7. 7 root 5. The radical had to be the same, so it stays the same. And now we're done. That is it. All right, let's look at this one. Radical 5. 5 does not simplify, so that one is done. You go to 3 root 7. 3 root 7. 7 also doesn't simplify, so that one's done. But does it match the 12 radical 5? The 7 and the 5 are different, so this is a completely different kind of term. So I'm going to underline it twice because it doesn't match the first one. 6 root 7. It's simplified, and it matches my second term, so I'm going to underline it twice. 8 root 5 matches my first term and is simplified, so I'm going to underline it once. So this one, they don't all fit together. That's okay. I just am going to combine like terms just like I would any other time. This one, actually, there's no like right or wrong way to combine them. Like usually when we're combining like terms, we put them in like alphabetical descending order. Square roots don't have an order. Just make sure you combine them properly. So since my root 5 is the first one, I'm just going to put that first, but it doesn't really matter. So 12 minus 8, because of the subtraction sign in front, is 4, and that one was radical 5, so it stays radical 5. And then I just put together the 3 and the 6. So 3 plus 6 is 9, and it's positive, so plus radical 7. And that's it. That answer just has 2 terms because they were different. Okay? And that is it. Hopefully that makes sense. If you need help, as always, let myself or Miss Bowerman know. You're going to do the operations with radicals worksheet. And you have made it through all your notes. Woohoo! All right. Bye, guys.